Alrighty.
Eh, yeah, the wiring is the whole project is confusing. I kind of have to go on the website.
Yeah, there's lots of pieces to it. Yeah.
It's different concept. It's just knowing how to code any of it. Oh yeah, I have to go on like and find an CIS website about Enigma and just read all the technical documents for the part stuff.
So if there's two pieces to it, right? The first part is we just want to imitate what it does. We don't need to do all of the things it does. We don't need to be exactly the Enigma machine to write code that acts like Enigma because we don't have wires. We're not going to physically wire anything here. And we're not giving it all of the really cool settings they have later on where they can like spin the inner gear and do all sorts of other fancy things here. We're just saying, tell me which three rotors and tell me what position they're in, right? So you kind of spin them that many times, essentially, right? And then what are your 10 pairs to get your plugboard settings? So when we look at that Wikipedia page, right, the flow for how letters get translated is this little chart down here, right? You push a button for a letter, okay? It goes through the plugboard, may or may not get mapped to another letter, and then it goes through the rotors, right? There's step 3 through the plugboard, and then through the rotors, hits the reflector, comes back through the rotors again, back through the plugboard, and lights up a letter. And these have to be paired, right? Because if you put A in and you get D out, if you reset the machine back to where it was here and you put D in, A is going to come out, right? Because that makes the circuit here. Because that's the way you can decrypt the messages. So they're all paired. So as it goes through, right, we put a letter in and it may or may not change. We put a letter in, it may or may not. And it's going to change the rotor. Going to change the rotor, going to change the rotor, change the reflector, change the rotor, change the rotor, change the rotor, may or may not change at the plug board, and it spits something out. Right? They're mapped. So when we're building it, we just need to go through that sequence here. And you can add in those small pieces later as we go here, right? You can start building it where things don't necessarily have to rotate yet. How do I do a mapping here for letters here, right? All the little different pieces here. So this is much more about problem solving, solving problems in code. We're using this object-oriented design because that makes life easier for us. I know there's a solution out there, and it's only like 20 lines of Python code, but it looks like nonsense. If you went and searched like Python Enigma, they're out here, but they're awful, right? Even the chatbot wants to give us this terrible solution here, which doesn't really make a lot of sense. The reason why we like object-oriented programming is because we can look at it and make sense of it. We like objects. We like things that we can interact with. We like the classes having attributes. So I know, oh, okay, well, it knows what step it's at here. Oh, it knows, okay, how do I get my mappings here? I got lots of them. Uh-oh, I think we confused the chatbot.
Um,
Didn't it work last time? I thought we got a chatbot last time.
I'm gonna have to like redo my stuff, but I go see the light right now. I got multi right. Through the plugboard thing, so I did what I made go through the plugboard, go through the rotor, and instead of going through the plugboard and then going back in, um, I just kind of had to go out, go through the plugboard again, and then to go to the output.
I didn't follow that, but it should follow the sequence, right? Plugboard, rotor, 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 reflector, rotor, 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 the other direction, plugboard, give you an output here. Let's see, did it give us anything? It's still something went wrong. Go for it here. Go figure.
On the wiring, once it goes back to the plugboard for a second time, it goes back to the rotors again for giving an output. But I didn't do that. I just gave the output right there.
So this is one solution here. This object oriented at all?
No.
No. And it goes A, B, C, D, E, F, G, H, no I, J, K, L, M, N, O, S. These are terrible variable names. Like reading this is awful here. Right. Okay, sure. We're looping with I. S is probably what, some sort of output somewhere here. But this one doesn't even let you like set the settings up here. But like you can see, there's other things out here. But why we want it to be object oriented is so we can make sense of it, right? Just having a short program here is not necessarily a good thing if we don't understand what it's doing. Yeah.
Boy, I do know that like when we have the users input settings, they'll get put into an Enigma machine.
Hmm.
But then the confusing part is like, what is the Enigma machine code? What does the Enigma machine plus code do with all that stuff?
Well, it has to create the rotors and set up the rotors, right? You tell it which three rotors is okay. Here's my three rotors. You tell it what positions they start in. It goes and spins them.
Think that concept, but I don't know how you're supposed to code that.
So the Enigma machine knows about all of its pieces here. Right? It knows about its plug board. It knows about its three rotors. It knows about its reflector. So it will have instances of those things here. And if you pass the Enigma machine those settings, it will go set up all of its subcomponents here. We don't need to set up subcomponent by subcomponent by subcomponent and hand it all to it. Like that makes it hard to use. You know, say, okay, hey, let's start. Here's your settings and go. Yeah.
It's almost impossible shows simple file. I mean, such like other stuff. Like,
So the easy way to do the stepping is when it goes from position 26 to 1, you step the one next to it.
so do we have to implement double stepping, right?
No.
Oh.
No, and that was an optional piece that they didn't add until later. Some of these things they got them to be more interesting and complex. Um, we don't have any of that. Right? We're just trying to do the basic version of it here. So hey, if this one starts at position 24, although it's for the one on the left here, so it's probably never going to rotate, right? Because 26 times 26 times something here. I can't math right now. All right, now I'm curious. What is 26 times 26? So if your message is more than 676 characters, you might finally step the third rotor, right? And or kind of depending on where these ones start too. So if we started them at 12 and 11 here, so if this one starts at position 11, 15 more characters in, it's going to hit 26. The 16th character, when it rotates, it goes from 26 to 1, and now this one shifts from 12 to 13. And then 26 more characters later, it'll rotate again. 26 more characters, it'll rotate again. So we might, depending on what you set it at, rotate the third one eventually here. But that's probably a lot less common here. And double stepping gets to be more obnoxious because then you need more settings. But if we write it with a nice object oriented approach here, it wouldn't be that hard to say, okay, when else do you step other than going from 26 to 1? Right? We can add in another attribute and then we can step when that happens. Right? It wouldn't take lots of extra work here if we design it well. And that's another one of those goals with object oriented programming. Things are changeable. Right? Most of the software we use in day-to-day life was written a long time ago. Maybe not super long time ago, right? But it wasn't written yesterday for most of our software, and it's been maintained, right? When you think about software engineering, a lot of time, energy, and effort goes into writing programs, right? In this software development lifecycle, you come up with an idea, you start designing it, you start implementing it, you test it, and then you actually use it. You want to be using it for the longest period of time here because then you get the more return on your investment. Companies don't like throwing money away, and software engineers are expensive because there's only so many of us who can do so many things, right? Still happens to be a relatively hard to learn skill. Despite my chatbots and all these fancy things here, I love my dear wife, but she is not releasing an app in the App Store anytime soon. Right? She's an early childhood education major. Even with chatbots, she's not going to publish an app. It's just not happening. You still need some sort of level of technical skills here to do these things. And then when the chatbots don't do what you want them to do, you have to know how to take it to the next step here because the machines still aren't smarter than we are. It's going to be a little while, right? If it ever happens. I don't understand this. Is it something general intelligence or whatever happens to be? Yeah.
Oh. So like the corrections mentioned the postboard and reflector classes, but no parameters for them.
So the reflector should always be the same every time. Right.
Like,
Technically, you can spin the thing, but again, we don't need that level of complexity here.
doesn't the reflector have mappings?
Yeah. It's like a rotor that doesn't rotate.
Is it the same mappings that the plug board has, or
No, the plug board is just 10 pairs. The reflector just changes. Okay, and A goes in and maybe it maps to C. C goes in and maps to A. Whatever happens to be, we'll randomize it.
so plug board doesn't have things?
This is the plug board. So whatever 20 letters you give it are the plug board settings. Right?
Or the actual string, the reflector's mappings, like A, B, B to A.
No, we need to randomize something here and randomize 13 pairs of letters with for the reflector, right? The plug word is you would pick here. They actually would physically plug these things in to do one more level of scrambling here. I think at some point they could change the reflectors. Again, we don't need to get to the super most complex one here. Once we've got it running, we could then go modify it and tweak it and make it a little bit more complex if we so care to. Um, but that's just an exercise at that point here. We're just trying to have a little fun with this one.
Reflector have the randomized two pairs.
Yeah, just like the rotors, but it doesn't rotate. You okay so far? It's a lot. It's okay. But it's a good exercise in trying to do some problem solving, trying to do some design, so this stuff makes sense here, right?
I don't understand how where everything goes in the inits in the code.
Let's just make if you hand it in it, it makes it easier to create, right? So you should be able to make an Enigma with a bunch of settings here, and it will go make all of its subcomponents. You don't want to have to make a bunch of rotors and spin a bunch of rotors. Like you want to make this easy for somebody. Give me the settings. Let's go and run. Yeah.
Oh, so the rotor number is like 5. Those are little rotors, and you kind of have to look up.
You don't have to do any of that. That's way more work than you need to do. We don't have to use the actual letter settings here. We just make it up. Right? We're not rebuilding the actual physical device here. You can go be an electrical engineer if you want to do that. Right. That's a lot more work. If it's like 5 lines of code to randomly set these things, and then I can make not exactly, but almost infinite rotors. Right? Yeah, you see it.
And I think the thing with the reflector is kind of weird. Let's say you put an A into a rotor and get an E out. Well, with the reflector, if you put an E in, you will get an A back out.
It should have different settings.
No, I mean, like, kind of how a reflector works. Like, you send backwards, backwards.
Well, it's one mapping, right? So it'll change the letter one time, right, as it goes through. So whatever it went in, it'll give you a different letter back out. This is the reason why you never got the same letter repeated. So if you were encrypting the letter A, you would never get a letter A in the encrypted text. And this was one of the big flaws in the Enigma machine that let us crack us, the whole team, the Polish scientists, and then Alan Turing were able to crack it because of that.
So is the reflector basically just an unchangeable plugboard?
Rotor, not a plug. Because it maps all the characters.
Oh,
Plugboard only has 10 pairs. Yeah.
so what if in the you have to so you have to randomize all the pairs. How do you check if a number how do you check if a number that I gave you was already there, but it doesn't use that number again?
There's tons of different ways of doing that. Pick whatever approach you want.
Well, how do you check specifically if the number 1, for example, is already in there?
Lots of ways to check if you see already a value. That's one of the things we're working on, right?
Because when I randomly seeded it before, it gave me stuff like 5242 and then the other 22.
Yeah, and you have to make sure you don't take the same number twice, or there's different options. You got lots of ways of going about it. Yeah.
So just to make sure the reflectors, if you map A to E, it's not going to map E to A.
No, it is. It's still the pairs, but you only go through it one time. Right. All the other rotors you go through one direction and then you come back through the other way.
Yeah, but then reflector is right at the end, so it just comes back to
what's in the middle.
right.
Yeah.
If your plugboard pair was AX, your reflector pair is not also going to be AX.
It should be random, or predictably random, so it's the same every time. We just pick 13 pairs randomly. The plug board is whoever's entering it gets to set what they want their pairings to be.
Is it the board use one of the rotor numbers we don't use for seeding it?
The plug board has nothing to do with rotors. It's not seeded. It's not
No,
random at all.
not board reflector.
Yeah, use one that's not a rotor number. Right? Works out really well. Nice and easy. All right, should we move on to new stuff? All right. So we're going to talk about data visualization, which is super cool in Python because there's a really cool library here. So it's matplotlib. I don't know why, but it is. So matplotlib.org is the site here. Very fine folks give this away and have put a lot of time, energy, and effort into it because software engineers are weird. And for some reason, people like making open source tools. They're like, hey, look, I did a cool thing. Everyone should play with it, which is super cool. So we got to take advantage of this. So this is almost anything you can imagine plotting, graphing, you can do with Matplotlib. Maybe not exactly 100% of everything you can imagine, but pretty close. So real quick, if you look at the examples page here, they show you, hey, here's some ways with pair data, X and Y's, right? So we can do plots, scatter plots, bar charts, stem plots, fill between stack plots, stairs plots here. You can do statistical distributions. People love doing these, lots of fun here. Histograms, box plots, error bars, violin plots, event plots, histogram 2Ds, hex binding, pie charts, ECD. I don't even know what an ECDF is. That one sounds fun here. But you can do that. You can do gridded data here. These ones get really interesting looking here. The IM show, a PC color mesh, a contour map, a contour F, barbs, quiver, and a stream plot. You can do irregularly gridded data with try of these instead of just pairs, right? Oh my goodness, these get fun. 3D and volumetric data. 3D bars, a fill between, little spiral plots in the 3D, quiver plots in 3D, scatter plots in 3D, stem plots, plot surfaces, plot try surfaces, voxels. I don't know what a voxel is. This gets to be fun. Anybody taking a lot of stats? Look at these things. Plot wireframes. And they'll give you all the code. You can even run them right in Binder, which is really cool. You can go right online and run these here on a browser. It's not the best experience, but it's nice and quick and easy for people to play around with. Again, I really like my IDE because that's what I've had for years and years and years, and I really like them. Coding in a browser is just not, it's kind of fun and all. Maybe it'll be the future because then you can make it run on someone else's machine and you don't need a really powerful machine sort of thing, but we got options. So documentation and reference, anything you want to go look at here, it will show you how you can go make these ones here. So, hey, here's a bunch of things we can look up here. Their documentation page is fantastic. So if you think of a plot you want to make here, oh my goodness, I'm in the wrong page here now. Plot types, right? Plots. They'll give you, here's some code you can use. Cool. I don't know what this one does, but let's go grab it here. Let's try it. So it uses another library, NumPy. We'll spend a little bit of time with NumPy after the midterm, looking at some of the cool things it does. This is a numerical manipulation one, NumPy. It's probably NumPy, but I call it NumPy. I don't know. I come up with bad names for things sometimes. NumPy makes a lot more sense now. It's PY for Python. So when we go install it the first time here, let me make a new project. This is, I don't even know what week we're in here now, right? What week is this? It's week 8? Week 9? Week 9. Visualizations here. Let's give that a try. The first time we go use it, if you've not installed the library before, it will say, hey, let's go install the library. If we're using our virtual environments, you'll never have used it before because you start with a fresh copy of Python. Again, it's a good thing to do. Installing Matplotlib, probably fine. When you start getting into some of the weird libraries that we use later, though, different versions make the difference. And you get out of sync really easily. So again, the virtual environments are really nice here. It's going to tell me, hey, I don't know what Matplotlib is. I don't know what a NumPy is here. So again, in PyCharm, you just say, hey, let's go install the package. Yes, let's go install the package. If you don't have that, right, you can go back and you can do it by hand with pip. I don't like using it because it's a big pain in the butt here. It's actually not that hard, but you can use the command line installer here if you want to. Those things are fine. Install that one, and then we'll install NumPy. Really should say it the right way here. Come on.
should you install it globally or just in pod?
just to the project. So it'll put it in your cache, so it's faster to download each time. It'll keep the cache of packages you've installed, but it won't add it to the virtual environments until you tell it to add. And then it's really quick. So we did matplotlib. It's installing it right now. And then you can always go see these in your project settings. Again, this is kind of that magic that happens behind the scenes. You go to our project settings, our project Python interpreter. Here's the list of tools it's installed. So just by installing matplotlib, it installed a bunch of other ones too. Good news, you get a bunch here. These are dependencies. For those of you cybersecurity minded people here, this is why supply chain attacks are so dangerous, because any one of these things could be attacked and someone could add a vulnerability to it. I probably have no clue. I'll be okay. I don't have any clue if any of these have any vulnerabilities here. I kind of assume because it's so widely used that it's probably safe, and smart people are probably looking at it here. That may or may not be a good answer there, but that's why we run into trouble here, because we depend on other people's software that depends on other people's software that depends on other people's software that one guy somewhere wrote and maintains because they thought it was cool. So, yeah. What?
So install it.
Matplotlib.
I'm going to into there.
Yep. And then for some reason, they always set it. They can name these things when you import. You can say, hey, I want to call it a short name here because pyplot is kind of long here. So we're going to import it as plot, right? Without the O, because every time you want to save a letter, you save trees by saving keystrokes, I'm sure. So we just copy pasted this example in here. We hit run, and we should get a pretty little picture. We got a pretty little picture, figure 1 here. And it is like draggable. It's nice and easy. You can move this thing around. You can even save these figures out to images if you so care to, and say, hey, here's my PNG file for it. You can do all sorts of fun things here. You can automate that stuff too. And then automate emails and send reports and do all sorts of fancy things here if you'd like. Lots of cool options. And as I move over my plot, you can kind of see in the bottom left, it's telling me what my X and Y are as I move around here. Like plotting a sine wave. Is that what we're doing here? Looks like a sine wave. It's a little bit off here. I'm not quite seeing the legend here, but it's pretty close. So goes and does that. Lots of cool examples of things we can plot. It's really fun. So one example I like to do here, it's getting slightly old, but it's linear thinking. Aha, it's in my search history here. It's a little Harvard Business Review article here about linear thinking in a nonlinear world. That's your hint here to the question here. So the premise is we've got 2 fleets of vehicles here, and we've got enough money to upgrade one of them. Again, it doesn't have to make a lot of sense. That's okay. So one of the fleets of vehicles we have currently are SUVs, and they get 10 miles a gallon. Okay, we got a bunch of these SUVs on the road for our company, whatever happens to be. They get 10 miles a gallon. And another fleet of vehicles are sedans. They get 20 miles a gallon. Okay, equal numbers of each, and they all travel exactly 10,000 miles a year. Again, it's a thought exercise. Just go with it. Doesn't have to make a whole lot of sense. Okay, we've got enough money to replace one fleet, either the SUVs or the sedans, with a more fuel efficient vehicle. Probably got a tax rebate for doing this too, right? Because of course we love to give companies tax rebates for things. Because we want to meet our sustainability goals and tell people how green we are, right? We're going to invest capital in being more green here. Instead of doing meetings over Zoom, we'll make people drive in. So, anyway, which upgrade is better? Should we replace our SUVs that get 10 miles a gallon with newer SUVs that get 20 miles a gallon? Or should we replace our sedans that get 20 miles a gallon with sedans that get 50 miles a gallon? So someone said B. Which one's better? I got 1 vote for B. Raise your hand if you vote for B.
I need more information to decide.
This is all the information you need. All right, so only 1 other vote for B. Who thinks A is a better option?
I don't know. I'll just say it just to say it.
We have 1 vote for A. We got a bunch of people who aren't voting here. Which one's better? Just trust your gut here, right? Which one's going to be a better upgrade to give you better fuel savings?
Okay.
A couple more B's, a couple A's. Okay. Should we plot it out and make a graph and look at this visually? yeah, look, we can visualize some data here. Most normal people, when they're presented with facts, can change their mind. I'm having trouble believing that, seeing lots of adults in America nowadays. But in general, you present someone with facts, and the idea is they should be able to make a decision and change their mind and realize which was the correct choice here. We're going to try it here. And as we start working with data and working with visualizations, we're going to take a solemn oath not to lie with our data, because it's very easy to lie with data and manipulate facts with the way you present it here. People do it all the time to make themselves look better. It's not a good thing, though, right? We want to be honest with our data here. We tell stories with data. It's one of the easiest things to do here. We use the visualizations to tell stories. This is one of the fun things you get to do with data science here. And you paint a picture, but you want to do it honestly, right? There's like a whole set of misleading graphs. Here's a bunch of examples here. Misleading graphs, real life examples here. So lots of things you can do is you can change your vertical scale, you can skip things, you don't start at 0, you don't label it, you leave out data, inconvenient data that doesn't tell your story here. I don't think I can watch it on YouTube here because it'll strike my YouTube video. I can like sample it here. All right.
Just react.
That's right. As long as my face is in the corner, right, I'm just reacting. Is that fair use? I don't know how any of that works here. All right. So this one here. Oh man, that's kind of small here, but it's over 100 million people now receiving federal welfare here, getting people upset about the welfare state, as some people like to do. Oh, look, it's grown so much in this last whatever 2009 to 2011 here. Well, what you don't notice is the first number in the bottom left here is 94 million. So the growth here, if you were to start that at 0, doesn't look like a whole lot. Right? Because you start your scale at 94 million, wherever you picked it here, it looks like, hey, we've tripled in size because this bar is 3 times bigger. You must be 3 times the number of people on federal welfare. Well, no, whatever, that's that 97 million to 106 million change. So like 10%, something like that, right? Let's just not lie with data. So all sorts of fun things here. The tax rate. This is Fox News. Who's surprised here? Now and then, your tax rates are going way, way, way up. Look at that. It's like 10 times as many taxes. Well, no, it's 35% to 39% here. You just started your scale at 34. Right? Very misleading with your graphs here. The unemployment rate here. Again, let's just keep on bashing Fox News, but it happens, right? They do this all the time here. The unemployment rate data. It's not plotted in the right spot here. Huh. Who knew? They didn't put it in the right spot. 8.6 looks flat here instead of going down. This may or may not have been on purpose. Maybe this was just someone being dumb here. But that's very misleading. Right?
It says that 8.6 is greater than 9. What?
So you can do bad things.
Also, all those extra apartment. Right now, we're like
Somewhere around 4% unemployment. Yep. But apparently, there's an ideal rate of unemployment, which I've not understood here. I wish I had time to take more economics here.
It's almost 6%, mostly there's always people whose jobs are redundant, or there's people who quit their jobs and try to move in. If it's under 4%, that means there's so much demand that the moment you quit a job, 10 people will be begging you to sign on.
That's a good thing, right? Don't we want people to beg us to work for them?
It's bad. Makes like labor cost very high.
Is it bad when we make a lot of money for working?
No,
I'm sorry. I'm just being silly.
it makes everything expensive. Like how inflation.
Yeah.
If it's over 6%, that means like the moment you job opens up, there's 10 people begging them for it. Man,
You want ideal conditions to keep inflation at a reasonable level because inflation's good, but not too much inflation is bad, but not enough inflation is bad. The whole thing is, I don't know, it's fascinating here. I love my economics classes that I took. Wish I had time to do more, but anyway, so don't do bad things with your data. That's all. You can take a look at all sorts of fun examples here. And then the other caution I have for you as you start exploring data here is the correlation versus causation examples. There's a whole website here, if I can remember where it is here. That's example. I know it's out here. Spurious correlations. There we go. This one here. So viewership of The Big Bang Theory correlates with Google searches for how to make a baby from 2008 to 2018. There's a strong correlation with this data here. Just because data correlates doesn't mean that one causes the other, right? Hopefully you all have already heard this before, and this is not an aha moment for you here. But just in case you weren't sure, these two things are completely unrelated. They just happen to have the same graph, right? They're correlation. They don't cause each other. So just because data correlates doesn't mean one's causing another. There's another pretty common correlation, and it probably has a lot of causation related things here, but rich kids tend to do better in school. Some of that is causation because you don't have to have a job and you don't have to worry about food and you don't do all these other things here. You've got more time to be a good student, sure. Are they smarter people? No. They're just rich and don't have to worry about the rest of their life, right? So those sorts of things here. And this one's fun. You can just like keep refreshing the page and you just keep getting new ones. Right? Refresh? Random. Oh, I would need random. There we go. Random. The number of university engineering teachers in Kansas versus the National Lacrosse Champions final point. I don't know where they find these things here. Some of these are fun here. Let's get another random one here. Google searches for ice bath and inflation in the US. Apparently ice baths are becoming more interesting here. So anyway, we're beating the dead horse. So we're not going to do bad things with our data. So visualizing our data, we got lots of different options with matplotlib here. So, we were going to solve our problem here, right? That's right. I got distracted here. Our linear thinking in a nonlinear world. So let's go graph it, right? So we want to see how much fuel we're currently using, right? I mean, we could work it out on like the back of a napkin too, but graphing it's much more fun, I think. So we'll look at how much fuel we're using at 10 miles a gallon, and we'll look at how much fuel we'll use at 20 miles a gallon. We'll look at how much fuel we're using at 20 miles a gallon, and look at how much fuel we'd use at 50 miles a gallon here. And again, we want to like smooth it out here and have a line. It might be a whole lot nicer here. So let's take a look at that. So I'm going to leave. Well, let's get rid of all those examples here. Actually, I want to keep some of them here. So we don't need a style. We need some data. So we'll have our SUV's MPG, right? Is going to be a list of a range. Let's go from 10 to 21 because we want to get to 20, right? So we'll range from 10 to 20. Essentially, that's my list here. So now we've got a list of MPGs. And then we'll have our total miles driven here was, what, 10,000 a year? Right? And then we'll have a gallons used then. Gallons used is going to be a new list. So we want the values for how much fuel we use per miles per gallon.
But the range close to 20 is 20 miles.
I'm sorry?
The range close to 10 20.
No, because
I want to start at 10. I want to go up to 20. So I've got to stop by 21.
yeah, he's thinking of Brandon's that.
So we want to take our MPGs, our total miles driven, divided by the MPG for MPG in my SUV MPGs. These list comprehensions, if you like them, great. If you don't like them, that's okay. Do it with a loop. It's not going to hurt anything. I've tried to do more of these here because so many other people use them online, and I always get confused by it. I was like, I want to not be confused so much. So I think this will do it. So like here's the looped part, and then here's what we're appending into the list here. So this will tell us how many gallons are used at each level of MPGs, right? So at 10 miles a gallon, we should use 1,000 gallons. At 20 miles a gallon, we should use 500, right? I think that math checks out. And we'll see whatever that scale is along the way here, right? So that's our fuel savings. So if I want to just plot that one here then, right? I've got an X and I've got a Y. We don't need X and Y now. We don't need subplots, so that's fine here. So we're just going to plot one of these things here. So py.plot no, plt.plot. Plot.plot, then we have to give it an x and a y. So the x-axis here should be our MPGs, right? And then the y-axis should be our gallons used, right? And we don't need to change any other settings here. You can do all sorts of other fun things with those. You can change your line widths and change your markers and do all sorts of fun things here. We don't need to do any of that here. And then we want to show the plot, right? So this should show us, we haven't added labels. We should add some labels here. So at 10 miles a gallon, right, we're using 1,000 gallons of gas per vehicle. At 20 miles a gallon, we're using 500, right? Not a bad savings here. Now, if we wanted to keep on going here, we could keep going from the sedans. We could keep extending this out to 50 here if we wanted. Or we could do a second graph, second plot. We got lots of options, however you want to look at this one here. But essentially what we want to do is show the savings, right? So the base gallons used then, so to calculate our savings, instead of calculating how much is used, we want to have the base SUV gallons used, we said was 1,000, right? So then what we want to get is our MPGs subtracted from 1,000. Our gallons used subtracted from 1,000, right? If we normally use 1,000, how much are we saving as we increase our miles per gallon, right? So we want to take our base gallons used subtracted by how many gallons we're going to use as we increase our fuel efficiency, right? Stop it and run it. So now we see at 10 miles a gallon, we've saved nothing here. At 20 miles a gallon, we've saved 500 gallons per SUV, right? That's the point we're looking at here. So if we want to extend this one out here, that was SUVs. Let's repeat it again then for our, this is SUVs, gallons used, SUV. And this is actually saved now, right? Gallons saved, right? So then we'll replace that one with saved, okay? And then let's repeat it again for our sedans. So same total miles driven here, but these ones are going to change. Where did I paste that one in here? So the sedans at 20 miles a gallon, we know was 500, right? We can do that quick math. So every sedan uses 500 miles a gallon now, right? And we want to range from 20 up to 51, right? 20 to 50 to see as our fuel increases here. So how much did we save then as we start? This is sedan MPG and sedan gallons saved, sedan MPGs. Let's see, for in sedan MPG here. So here's our second plot. Here's the second graph here. Now, it looks a little silly putting them with this act. Again, it's okay. Don't worry too much about it here. But starting at 20, we save nothing here. Going all the way up to 50, we're saving about 300 gallons of fuel per vehicle here. The SUVs are saving from 10 to 20, 500 gallons here. So which one gives us a better savings in fuel to replace our fleet? Which fleet's better to replace? Which one? Or this is fuel savings. So this one we're only getting 300. This one we're getting 500.
I don't know if you
No, this is fuel savings. We changed it. Yeah, fuel savings. Right? You want more savings. So the SUVs going from 10 to 20 saves more fuel, even though 10 to 20 doesn't seem like as big of a change as 20 to 50. Right? Because you have diminishing returns. For every increase in miles per gallon, you save less and less and less fuel as you go. Right? So we can show that one too, because that I got a couple of funny looks here. So if we had our total miles driven, let's leave that one there. This is fuel used, our MPGs. We'll go from a list of a range. Let's go from 10 to 51. We'll show the whole thing here. This is MPGs, or all MPGs, I guess, right? Because we don't want to rename it here. And then again, we'll do our calculation here. This is, we want gallons used, right? Gallons used is going to be a list of, we want the base total miles driven divided by the MPG for MPG in all MPGs. And then we can plot that one and show it. We want all MPGs for the X, the gallons used for the Y. And we'll show our plot. So let's just run just this first one here. Let's run. May I do just that bit? See if that one works for me here. Nope. Shoot. I did a bad thing. I was trying to just have the one. Oh, goodness. We broke Python. All right, I'm just going to comment these plots for a second here because I don't want to show the other ones. There we go. Just the one plot. Okay. So this is gallons used here. You see it's not linear. That was the hint from the title here. It's linear thinking in a nonlinear world, right? This curve is not linear. So as we extend it out, go further and further and further and further here, we're going to save less and less and less fuel, which is a little bit sad for our auto companies, right? Like, hey, we need to increase our fuel efficiency, but going from like 40 miles a gallon to 50 miles a gallon, you don't actually save a whole lot, which is kind of sad. Like if we pump this all the way up to 100 here, you don't save a whole lot here between 50 and 100. So at 50, we're at, we say, 203 or so, looks like. Gallons used, probably close to 200 here. But at 100 miles a gallon, we're using 100 gallons, right? So to double from 50 to 100, you've only cut your fuel from 300 to 200. Is that right? 200? Oh, 100. 100. That's right. From 200 to 100. So doubling the fuel efficiency, we only use half the gas from that point here. But doubling it from 10 to 20, you saved half. But the savings we get here, right, is much bigger because it's not linear. That's all. So being able to plot these things and show graphs to show a picture here, adding in some titles and labels and legends would be really nice here. But should we ask the chatbot? Do you think it can do that here? Let's ask the chatbot here. Because I don't even remember how to do it right now, and I think it can do it for me here. So given this plot, please add a legend for fuel used, label the x-axis as MPG and the y as fuel used. Oh, wait, that's right, not a legend. You just want to label the axes, right? Is that all we needed? Just add some labels here. Hey, look at that. Plot X label, plot Y label. All right. Probably could have remembered that one. I feel a little bad here, but that's okay. That's a little bit nicer, right? Fuel used and MPGs. We can add in other things here. You can add annotations. You can call out specific highlights, which is really fun. Lots of fun things we can do with data visualization and graphing here. All right. But again, using it to illustrate real world situations is much more fun than just here's a silly little example here, right? Trying to plot some actual data is much more fun here, right? And they'll take you through whatever our savings are and things. So this article was fun. You get a couple free Harvard Business Review articles. I think if you're on the network here, you can get to them as well. Just don't be on the guest one because library access and whatever nonsense here. So same idea with savings here. They do another example here. This is savings for paper towels here, which is fun. Why we fall prey to BOGO savings so often here, or like, hey, this one's on sale by so much, or this one's 33% more than the other one here, right? People are really bad at math. And that's okay. It's not always super intuitive here when you look at stuff like that. Like, hey, this roll's 33% bigger. Bigger than what? And, just because it's bigger, does it mean it's going to be 33% more? Or like trying to figure out those savings is tough here. I always like grocery store math. Trying to go price per unit here is really fun. But measuring your paper towel usage by square foot doesn't work really well, right? Usually it's about like how big of a piece you tear off of. All right, now we're getting silly, right? But if you tear off a big piece of paper towel versus a half sheet of paper towel, you can probably get by most things with that half sheet anyway. Or maybe if it's 3 inches taller or 3 inches shorter, right, you're going to change your square footage here. Those sorts of fun things here. These are not the kind of things you should keep yourself up late at night thinking about, but they're fun to ponder sometimes. All right, so go back to Matplotlib. Other visualizations here, which are really fun. Let's look at histograms are really popular, right? So this one is looking at random number generators. Look at that. That's fun here. So we can get a little histogram of it. So let's go grab this one here. So we've got that plot here. Can we do another plot? I don't need to import again. I think, is it going to show me a second one? Oh, I'm going to screw it up here. So we'll change. There's the other plot. Okay. After we close the first one, we get the second one down here. So we can see now the X and Y are not super helpful in a histogram, right? Knowing where you are here, right? Not the most useful as you go. Wow, it keeps like zooming in as I go. That's weird with the mouse, right? But fun to be able to plot some histograms here. So normal distribution here with a scale, a size. So this NumPy library does all sorts of other cool things here. If you're doing number fitting and those sorts of things you're going to do for statistical analysis or fitting things like from your scale from 0 to 1 to make it easier for regressions and things like that, NumPy is fantastic. NumPy is fantastic for that. Lots of great things here with the NumPy library. And again, if you're not sure how it works, we just go look it up, right? You can go find NumPy. And we can check out some documentation here. Look at the user guide. Which one do we want to do here? Doing array creation is pretty popular here. They even have a little chart for people coming from MATLAB. MATLAB is awful because it was not written by software engineers. It was written by engineers. And the way they write software is different here. And it's I find it very unfriendly coming from a software background. My engineering friends are like, oh yeah, MATLAB, because that's the only thing they know. They're like, oh, this is great. I'm like, no, that's hot garbage.
It also doesn't use 0 indexing, it uses 1
Yeah.
indexing.
Because to be fair, normal people don't start counting at 0. It's just a convenience for computer science here. But because we've been well trained to always start counting at 0, which is great. But my wife yelled at me when I started to teach my little kids to start counting at 0. I'm like, all right, kids, 0, 1, 2. She's like, no, stop it. Turns out that's probably not helpful, and little kids have a problem understanding the concept of 0. But us computer science people who are smarter than the rest of the world, obviously we know you start counting at 0. Right? Sure. Yeah, so all sorts of fun things with NumPy here. You can make arrays are really nice here. So doing n-dimensional arrays are really easy with NumPy. And create some really quick ones here as you go and give you some good distributions. Trying to think of it's like fitting. We've got data we want to fit, so we can graph it a little better here. That's going to take a little bit longer here. The unfortunate thing with these is unless you're using them day in and day out, we're not going to remember all the different features and functions that we have. So again, sort of the shotgun approach. Here's a lot of cool things you can do in Python, right? You don't have to memorize any of it, just know it exists and then know where to go look it up, right? I think that's why these chatbots really shine for us here. They can give me quick examples of things here and I can go take it and run with it if I know it exists. If I don't know that it exists, it's hard to ask for, right? So, hey, here's lots of fun things. How do I do a graph like this? It can give us examples here. Documentation page here is good. Got lots of fun things as we go with our plot types. Just go and ask, right? And then take it and tweak it here. These ones have ridiculous numbers of options here when it comes to what I want to set all my different graphs to. Setting X limits and Y limits and setting this histogram here. I've got specific bins for my histograms here. Oh, arrange is what I was thinking of. NumPy arrange here. So evenly spaced values for a given interval here. So this one's super handy for building out axes, right? So instead of having to do it by hand, right, it will calculate it for you really nicely with whatever particular values you're trying to get here. Doing this from -3 to +3 with a step of 0.01, we could do that pretty quickly, right, with a little list comprehension, but we don't even need to do that at all with NumPy, right? To say, hey, give me that axis or give me that list here, right, from -3 to +3, stepping by 0.1. Just do it for me. So people have gone through that pain before, and we've added that into the library because people are fantastic and they gave us cool libraries for us to use. Has anyone gotten any info back from the company contact? I think 2 people, when I looked at the spreadsheet last, had some data there, but one of them might have known somebody who works there. They're like, is that okay if I just ask the person I know. It's like, yeah, that's great. So hopefully we get a small list. We're not exactly out of time yet, but within the next week or so, um, within 2 weeks, we need to have a list of libraries for us to look at. Yeah.
I have a question on, does it have to be someone from that company list?
If you know somebody somewhere, that's fantastic, right?
Like, for example, a single high facilities in different heights, it's like the community center, different heights. And I work there also, and can I use their
Sure.
database?
Yeah. Yeah. We just want to know what libraries are people actually using out in the wild, because we can look up, popular Python libraries, but it's not as fun to know like, hey, this one they're actually using here. And that sort of thing. If there's a company that you're interested in working for at some point in your life, it may or may not be worthwhile to go look at the libraries they're using and brush up on them here. A lot of times you can just look at their job posting and be like, oh, you want someone who's familiar with this, this, and this. You're like, okay, sure, that's fine. Right? There's lots of ways of going about it here. So if you're not getting responses back, you could go look it up on job postings. That's fine too here. But look, here's a list of all bunch of popular Python libraries. Thanks being here. There's a pretty good list here, right? JSON, that's a good one, right? Requests. Hey, we did some requests. Word to Vec, if anybody likes, oh my goodness, natural language processing. Word to Vec is very popular. One of the guys who was a grad student here did a whole presentation on that, which was really fun for his PhD. I was able to sit on that and didn't understand half of what he said, which is really fun. Um, Fast AI, Pickle. Pickle's really nice for serializing things. It'll put stuff in JSON formats for custom classes here. Generally, you can't take a class and put it into JSON, but it's really nice to be able to just dump JSON data, so Pickle's good. Again, lots of fun ones here that we could look at. Yeah, but Googling is only so interesting to find that list versus knowing what people are actually using out there. We'll probably have a lot of overlap as well. Like a lot of people are going to use pandas or NumPy. NumPy. Does it tell us how to pronounce it here? Is that on the Wikipedia page for this? It probably is, right? Pronounced. I don't understand how this works here. I don't know what that means. English, thanks. uh, sure. Is that NumPy? AI Pi? Pay? It's probably not NumPy. I've been saying it wrong my whole life. My life's a lie. That's okay. All right. So we're working on that. So on the 12th, we'll talk about the project. Right. We'll do the solution for the Enigma project. We've got one last individual project that we'll work on. It won't be huge, right? You'll be doing some visualization somewhere, right? I like these to be a little bit more open-ended. Go find some data, right? You can import data, whether or not it's from a database or a CSV file or from somewhere. You can go read some data and visualize it for fun, sort of doing some exploration here. So there's a nice, oh my goodness, what is it here? Um, oh, I should have written it down here. Data connection process. Oh, what's it called here? Copilot answer. Here we go. Is this it? Look at this pretty picture. It's cut out here. It's not even all. Wow, it even gives the whole thing here. This is kind of fun to explore data, right? It's not the largest one. Can I make it bigger? Is that? Hey, okay. It's a little bit bigger. Make it bigger there. No, that's the wrong search. Open in a new tab. There, now we might be able to see it here, right? I want to figure out what we're doing. Right? What are we trying to understand from this chunk of data here? And then you have to go get familiar with it. This is the hard part here because a lot of data is stored in really weird formats or messy formats or specific columns or weird types here. It's hard to just understand what it is without spending some time getting familiar with it here, understanding what's stored where, and then looking for patterns. This is trying to find correlations here or outliers or whatever it happens to be here. This is kind of exploring the data as we go and then ask questions, right? What does it make us want to learn more about here? Right? What else can we find? Doing testing and verification, making sure that what we think the data is saying it's actually saying. There's a whole fun thing when we do machine learning, right? You have a training set and then you have a testing set to make sure that when you trained it on a particular chunk of data, it actually works on another set that you didn't train it on. It's really neat. And then communicating it. How do we actually present that data, right? We can crunch data all we want here, but doing data science kind of work here, you've got to communicate it here. And again, with graphs that don't lie, right? We're going to be ethical about this here and not tell lies when we tell our stories here. So for the next project here, we'll go and look at some data and kind of do this process. It's the exploratory data analysis. Oh, EDA, that's what it is. Yeah, exploratory data analysis here. Looking at all these sorts of things here. So what do? We just go and understand it, kind of explore it, look for these things here, and then check it. So there's data.gov. Yeah, data.gov has tons of data available. There's tons of other places you can find data as well, but this has some pretty nice data sets you can go look at and crunch here. People really love traffic data for some reason. That's a pretty common one people like to look at here. Turns out there's more accidents on freeways than other kinds of roads. But again, there's sort of that correlation here. More people drive on freeways every day, right? If you've got millions and millions and millions of people driving on freeways every day versus tens of thousands of people driving on 2-lane roads, you're more likely to have accidents just because there's more people, right? Those sorts of things here. So you run into fun things like that. But we'll look at different data, have some fun exploring it just to get a little practice in before we go. So that next project won't be too large, be a little bit open-ended. We'll do a midterm review on the 17th. So on the 12th, I'll give you the sample midterm here. And on the 12th or the 17th, we'll go over the answers to it. It'll be short questions and then 3 long answer questions. The idea is you could sit and take it while I watched you. So that's terribly dull, and I don't want to do that. And making you do something in a short time period is kind of silly. You do have deadlines in the work environment, but very rarely are they like, you have an hour and 15 minutes to complete this task while we sit and watch you do it. It doesn't really imitate the real world very well. So for the midterm, I'll open it on the 19th. It's untimed, open book, open notes, open internet, not open neighbor. So you don't get on group chat and be talking to people about it here, right? It's not meant to be hard. This is our check-in. Hey, we've gone through 16 chapters in the PY3 book here. How'd you do? Right? It's supposed to be easy. I'll be honest. Like, the goal is this is easy for people who've actually done some reading and participated and wrote some code here. And then it'll be due on the 24th when we get back to class. Right? And then we'll pick up some Python libraries. We'll look at a bunch of different libraries as we go. We'll start working on the final project where we're getting in groups. So if you didn't put yourself in a group yet, go to people. You can self-assign to groups. We're going to do groups of 3 because otherwise we're going to have way too many presentations on our final exam slot, which is way too early on my birthday, but that's okay. We'll celebrate because we're done here as we go. So on the 22nd, each group will present what they did. Hey, here's some library we looked at. Here's what we did with it. Here's a fun thing. Right? It's 5 minutes, maybe 10 if you like to talk a whole lot here. You might ask a couple questions as we go. Should be a lot of fun. So looking forward to spring with y'all. You take care.